Dear students, welcome to another lecture in industrial engineering. Today's topic is line balancing. Now, line balancing, when we say line, we are meaning it is either it is a production line. Production line can be an assembly line. That means number of machines are kept in a line, and you see there are a number of stations, and the raw materials come to the first station. Some work is done on that raw material and it goes to the second station. Some more work is done and it goes to the third station, like that. When it comes out of the last station, you get the finished product. That is an assembly line. Or see, assembly line means actually mostly they will be assembling the things. But in production line means they may be doing major machining and such activities also. Okay, you see, assembly line is a special case of production line. Okay, so line balancing, when we are saying, that means we are balancing this production line or assembly line. What is the meaning? Why should we balance this production line? See, balancing means all the machines in the line, all if instead of saying all machines, we can say all stations in the line should have the same amount of work. See, the basic objective of line balancing is to distribute the tasks evenly at every workstation so that the idle time of men and machines is equally distributed. You see, now there are number of workstations, and in each workstation, suppose a machine is there and a worker is there. Okay, now this worker and this machine should have, when they are not working, then it is an idle time. So the idle time of these men and machines, either it should be completely eliminated, or it should be the minimum. Or otherwise we can say that all the people, all the workstations have the same amount of idle time. Okay, then we can say the line is balanced. You see, here is another definition, or the aim of line balancing. Line balancing aims at minimizing the idle time of men and machines in the production line. Now, line balancing, suppose we are saying we are line balancing the layout. That means what? That means arrangement of machine capacity to secure relatively uniform flow at capacity operation. Suppose in full capacity the machine the plant is working, then the flow is uniform. You see, all the people have same amount of work. The goods come from one workstation to another workstation, and it keeps moving because all have similar amount of work. Suppose each person works on a part for 10 minutes. So if we call that as this is cycle time or something. Okay, see, the product comes, the first man works for 10 minutes, and the product goes to the second man. So the next product the first man takes, and he works in 10 minutes, and by the time the second person finishes his work, the second part is given to the second man. You see, like that, you see, all people, if their cycle times are same, if the line is balanced, then there will be a uniform flow of the material, okay, when it is working at the capacity operation. See, a perfect balance, we are talking about an ideal case. A perfect balance is obtained when the assignments provide no idle time. If nobody is idle, you see, and nobody is idle means it is not that they are overworked. You see, their allowances and other things they will have. Okay, a person with all when in a he can work well and produce quality products for 8-hour shift, okay, with such pace if he is working. And if he is not having idle time, then we can say that such a line is a perfect it has perfect balance. Okay, see, the line balancing also aims at grouping the work and workers. See, suppose some activity may be of 2-3 minutes only. Another activity is 5 minutes. 5 minutes. Another activity is 10 minutes. Now, how to do it? You see, one fellow works for 3 minutes and sits for 7 minutes. The other fellow is working for 10 minutes. You see, that is not right. No. So what you have to do? You see, if small works are there, you have to group the works and the workers also in such a way so as to obtain an optimum balance of the capacities on the assembly line. Okay, before grouping the work, see, now how will you group these works? Now before grouping the work, what you have to do is you have to break the jobs into small elements, various small elements. You should break it. Okay, when elements are grouped, their total time is almost equal, which reduces the idle time on one or another machine. Okay, see, what is our aim is our man, the operator that is there at the machine, and our machine, these should not be idle. Okay, that should be our goal. Even in case we cannot avoid idle time, that idle time should be kept to the minimum. No, it is not that one person is for whole 10 minutes he is working, and as soon as he finishes another work, the semi-finished good is coming to him. You see, that means throughout 8 hours he is fully busy, whereas his neighbor is having only for 3 minutes and then he is sitting again. He is sitting idle for 7 minutes, and then again if the work comes, he works for 3 minutes and he sits 7 minutes. See, that is not right. That is not called balancing. Okay, the operation times can be adjusted by this. Now if it is like that, now you have to adjust. How are you going to adjust? By redesigning the equipment. You see, equipment can be redesigned. So most of the times in the assembly lines and all, we use special purpose machines. Okay, they are not like what you see in our workshop. You see, if a lathe is there, lathe can perform, is a general purpose machine, it can perform so many things. But if suppose only one particular type of work is to be done, all such features of lathe machines are not necessary. You see, the minimum that is required in the assembly line, such machines they will make it for order and give you will get the machine for lesser amount also, and it is doing your job perfectly well. You see, you can redesign your equipment, and you can change machines, you can combine the operations, and you can apply motion economy principles. That method study and work study we have studied. See, those principles we can apply, and these operation times should be adjusted. Okay, now let us move to the next thing. We have seen this. Yeah, next slide. Now, objectives of line balancing. Why line balancing need to be why it should be done? See, to minimize the total amount of idle times at workstation. Idle times are also called as unassigned times. Actually, they are willing to work. Worker will be willing to work, but you have not given him work. That is why you can call it an unassigned time. Okay, to minimize the total amount of unassigned or idle times at any given workstation. Okay, next is to eliminate bottlenecks, ensuring a smooth flow of production. You see, if all the material is coming, raw, finished, semi-finished products are coming to one particular person, and the work is piling up there, you can call it as a bottleneck. Okay, see, that is not a desirable thing. But what we have to do is we have to balance so that a smooth flow of production is achieved. Okay. Now another objective of line balancing is to determine the optimum number of workstations and operations in each station. You see, you have to decide the optimum number of workstations. You see, for your entire assembly line, how many workstations should be there, and in each station how many operations should be there. This is what we have to decide. See, so to determine this optimum number is an objective of the line balancing. Then to maintain the morale of workers, since the work content of different workers will not be of great difference. You see, by by balancing the line, what we are doing is, you see, we are keeping all the workers in good mood. You see, otherwise, if a person is working continuously, the other fellow is sitting, so naturally this fellow will complain. You see, why is that, I am working so much and this fellow is simply idling away, is simply joking around here and there. You see, he will complain. You see, if suppose all are having at least, if not the same 10 minutes, if suppose one person has 10 minutes, another person has 9 minutes, you see, then no, still, the workers won't complain. Otherwise, you see, they will be complaining, and they will have quarrels, and their morale will be down. Okay, for some of the people. Okay, so to maintain morale of the workers, it is necessary to balance their balance their their workstations. Okay, then another objective is to maximize the manpower utilization by minimizing the idle times of the operators. So this is self-explanatory. You see, the least idle they are means you are extracting the maximum from the workers, and to minimize intermediate stock or work in progress. You see, if the semi-finished goods are there in the middle. You see, suppose at in one place it is piling up. You see, that is also inventory. You see, that is not a desirable thing. You see, if any inventory, if any stock is piling up there, that is not a desirable thing. Okay, stock lying idle is money lying idle. That is the meaning. Okay, so zero inventory concept and just in time concept, these to utilize these concepts, what we have to do is, we have to minimize the intermediate stock, and you can minimize the intermediate stock by balancing the assembly line. Okay, another objective is to improve the quality and productivity of the assembled products. Okay, that is, as a corollary this comes, and to reduce waste of production or and delay. See, this is also another objective. Now, when we are balancing the line, there are some certain assumptions, which the the process engineer he makes. Okay, what are those assumptions for a simple assembly line balancing? The first one is the element time of each element is known. It says it is not that any of the workstations or any of the worker, how much time he takes is unknown. It is not like that. Everything is known. Then a precedence diagram is available. Precedence means, you see, like when you are studying, it's like a prerequisite. When you are studying machine drawing, say, so for studying machine drawing, you should have already studied engineering drawing. That is a prerequisite. Similarly, here also some precedence will be there. That means, before performing an operation B, you have to perform operation A. Some such condition may be there. So that precedence diagram it is available with us. That's what we are assuming. All tasks must be processed, that we cannot leave any more task unprocessed, and the fixed and variable costs of each workstation are same. The splitting of the tasks among two or more stations is not permitted. See, it is not that one person is working, come, I will help you, give me your product here, I will machine and give. Such things are not allowed. Okay, this and any task can be processed at any workstation. That's what is an assumption. See, that means it can be any task can be clubbed with any workstation. Okay, if it is not the case, then there you have to pay special attention and do it. Okay, then the station time is always less than the cycle time. Cycle time means you can say the total amount of time that a job is staying in one workstation. Okay, see, that time is always less than the cycle time. It should be okay. Then the assembly system is designed for a unique model of a single product. You see, like if you are producing tractors, this assembly line is for tractors only. One tractor, it will produce a tractor. Okay, it is not that that will be used for some other thing also, some other product is coming in the middle. No, they were a single product. The assembly system is designed and only that work they will be doing. Okay, now let us see how these lines are balanced. There is a method called heuristic method of line balancing. The heuristic method involves two stages for line balancing. One, determination of the priority order of the elements. You see, priority order of the elements means, you see, you have broken the work into number of elements. See, and each element, first you have to determine its priority. Okay, it involves drawing a precedence diagram. A precedence diagram you have to draw in a particular way, which indicates that the flexibility available for transferring tasks laterally means in a line, okay, from one column to another column. You see, if it is going horizontally, we call it laterally. If it is vertically, we say from one column in a column. Okay, you see, laterally means in a row. Okay, opposite to that row is a column. Okay, like that. To say one column to another column to arrive at most promising balance. Okay, you see, you have to make a precedence diagram. Okay, then assignments of elements to the stations subject to constraint mentioned above. Then the elements should be assigned, but when you are assigning, you have to keep the conditions that we have mentioned before. Okay, then the heuristic approach involves following procedural steps. One is the identify the job, identify your work, identify the work. Actually, it should be identify the work. Okay, first to take a job on work, and what you do is you break down the work into elemental tasks, or or smaller duration tasks, or you call them steps. For example, threading is a step or an elemental task. Suppose you have to make a bolt. Suppose, see, in the bolt, you have to make the head, you have to chamfer it, you have to make the head into hexagonal shape, and you have to the shank also, it may be partly threaded, and there or that also should be chamfered, and then thread should be cut on a smaller portion of the shank. Okay, now just in the such a thing, just the threading is one step of that. Okay, like that you break it into smaller elements. Then list various steps as under. Here is an example given. See, now the steps are, you call them as tasks, is in 1 2 3 4 5 6 7 8 9 are there. Okay, This one, its immediate predecessor. There is no predecessor for 1, there is no predecessor. So there is no predecessor for 1, there is no predecessor for 2. Okay, that means these can immediately start. Okay, the first task is taking 3 minutes, the second task is taking 4 minutes. Okay, and the third task, for the third task to start, the first task should have been completed. So see, that means for 3, 1 is the predecessor, and the task 3 is taking 2 minutes, and for 4, 2 should have been finished. Okay, so 2 is the predecessor for 4, and this is taking 5 minutes, and for 5, 3 is the predecessor, for 6, 5 is the predecessor, like that. Various predecessors, immediate predecessors are there. Okay, and here in the column you have the duration of tasks. Okay, like that. Okay, if we add up all these things, it will be 38 minutes. Okay, anyway, this is one example of the thing. Okay, next let us see here. Now what the next step is to sketch a predecessor diagram, precedence diagram. Precedence diagram, and mark stages to distribute tasks and write their task duration. Okay, see the same thing like this. Like this we have done. This is I think this is a different thing. This is an example, this is another example. Okay, now here there are tasks, they are numbered as, they are marked as A B C D E F G H I. Okay, now I see A and B are not depending on anything, C is depending on B, D is depending upon A, then E is depending upon C as well as D. So E cannot start unless C and D are completed, and E is taking a time of 4 minutes. You see, now we have to sketch a precedence diagram. Okay, now see in this diagram. See, now you mark a circle, and in that you put the number of this name of that task, that is A, and its time also, duration, you write at the bottom here. Now this is first activity A, first task A, and it is taking 5 minutes. Okay, and now see, for if you see the immediate predecessor, you can see that A should be completed for D. That means what? D, for D to start, A should be completed. So here you can put D. Okay, now B is not depending on anything, so B can start. See, now C is depending on B, so here we can put C. Now next, now when you come to E, it is depending on C as well as D, so now you put E either here or here. Okay, now but these arrows are showing like this. So this shows that for E to start, C also should have been completed, and D also should have been completed. You see, this is simple, it's not very difficult to understand. See, after E you have to write F. F is depending only on D. Okay, it's not depending on E, it is depending on D. So you can put F here because after D, F comes. Okay, and then after F, G. Now G is depending on E, so here after E you can put. Then H is depending on G, you see, like that straight line. Then I is depending upon F as well as H. So like this you have put arrows. Now what you do is, now you can draw a dotted line like this, and you can call this as stage 1. Okay, now it is see, this is a stage 1, this is a stage 2, this is stage 3, okay, like that. Okay, stage 4, stage 5, and stage 6. Okay, now let us see here. Now for this problem, assume that the maximum time available at any workstation is 10 minutes. Now here if you see here we have not done anything as it is. You know how it came. We have just sketched a precedence diagram and we have drawn lines like this. You see now if you add the timings here, no, if you call this, if you want to make this as one station, okay, this is taking 5 minutes plus 4 minutes, it will be 9 minutes. See, whereas this stage is coming to only 3 plus 3 6 minutes. This man will be working for 9 minutes, but this man will be working for 6 minutes only, whereas this one is only 4 minutes. Okay, this is coming to 9 minutes, this is coming to 5 minutes, this is coming to 4 minutes. Okay, you see it is like this. Is it balanced? No. Now suppose for this problem the maximum time available at any workstation is 10 minutes. Suppose it is like that. Then in other words, the cycle time is given as 10 minutes. The total duration of all tasks is 37 minutes. You see, they have told you that you within 37 minutes you should finish it. Which means the minimum number of stations required will be, you see, each is taking 10 minutes and in 37 minutes you should finish, means 37 upon 10 is 3.7, or you can say 4. You see, in 4 workstations, 4 is the minimum number of workstations. So 4 will be the number of workstations. Here how many stages we have put? We have put 6 stages. Whereas, you know, now we should try to minimize those stations, number of stations, to 4. Okay, the maximum number of stations may be equal to as many as the number of tasks. Or you see, actually how many tasks are here? 1 2 3 4 5 6 7 8 9. So here, no, this can be the total number can be 9. Okay, but provided, no, all are having equal cycle times. But now here we are not having equal cycle times, therefore we have to balance the line. Okay, so it will be tried to achieve the balance with 4 stations. Okay, 4 stations we will try to do instead of 9 stations. We'll see how to do it. Okay, now there are 2 basic concepts of assigning the tasks. See, now what you are doing, as we as we have seen here, what we have to redesign or reallocate the work. Reallocate the work, reassign the work otherwise. Okay, and how you can do it is, you can do it in 2 ways. You see, permutability of tasks. That means any number of tasks or steps of a column can be combined to make up their total time closer to cycle time. You see, in a column, you now suppose this is the column. All this column we can make as one thing, but provided it should not cross the cycle time. Okay, provided the total time does not exceed the cycle time. Cycle time means what? The time available at any workstation, at a workstation, is called cycle time. Okay, now the tasks of each different columns can be combined, provided the precedence constraint is, see, when you can combine here these tasks, you see that this A can start at any time, any amount of time, any time, and B can start any time. Okay, now here, now C and D can be combined, because see now, see, for this work, for them to come, see, if the precedence is agreeing, you can do it, you can combine them. Okay, then analysis is carried out column by column, and one can move to the next column only after the tasks in the previous column have been assigned to a station. You see, now here what is happening, you see, suppose this column is there, only 5 minutes, but it has in the column no other tasks are there to combine. Then if all the column tasks are finished to combine, then you can move to the next. Okay, you can horizontally move, and then you can combine the tasks. Okay, that's what we are saying. See, we can move to the next column only after the tasks in the previous column have been assigned to your station. Okay, now next, lateral transferability of the tasks. Say for making total time of tasks equal to cycle time, the tasks or steps may be shifted laterally. Laterally means in a row. See, we can shift them provided the precedence relationships are maintained. Okay, so these are the two concepts. One they're called as permutability of tasks, the other they called as lateral transferability of the task. Okay, one is, in the column itself you are combining, the other one, laterally also you are combining, like that. Okay, using the above two concepts and with a purpose to minimize the idle time at a station, that figure one is this figure. Yeah, this figure is the figure 1, can be modified as figure 2. This is a figure 2 in which task A and B, see, A and B are grouped and assigned. This is, we call this, you see, with a rectangle they have marked and put here as a station 1. So this we are calling as station 1. Okay, and its time has come to 9 minutes. Okay, so A and B are grouped and assigned as station 1. Then task C, D and E are grouped as station 2. Now C and D, if you take only 6 minutes, suppose you take this also together and you make this entire thing as one station, then this time is coming to 10 minutes. Okay, 10 minutes is accepted because our cycle time is 10 minutes. You see, it is not that in every place cycle time is 10 minutes. We are only taking an example and calling it as 10 minutes for different machines, for different assembly lines, cycle times may be different. Okay, now these three are combined and they are called as station 2. Now task F and G, this F and G are grouped. When you group, this is again coming to 9 minutes, so no problem. You see, first station 9 minutes, second station 10 minutes, third station 9 minutes. Okay, then these two horizontally can be combined, whereas tasks H and I are placed at station 4. Now this is station 1, station 2, station 3, station 4. This is taking 9 minutes, this is taking 10 minutes, this is taking 9 minutes, this is taking 9 minutes. Perfect. Okay, so each of these 3 stations 1, 3, 4 are idle for 1 minute only, whereas the station 2 has no idle time. Okay, so this is how the line balancing is done, and this type of line balancing is called as heuristic method of line balancing. Okay, so we have seen why the objectives of line balancing and what is line balancing and all these things. So today that's all, this one topic we will study, and we have finished it. Now we'll stop and we will meet again in the next lecture. Thank you.